In this video, we are going to look at logarithmic equations, but we're going to break it into two different forms. Let's look at form 1. This is where you have a combination of logs on one side of the equal sign and a constant on the other, or at least that you can get it in that form, so where you have logs and a constant. So the first thing we're going to do is we're going to combine the logs using the log properties. Remember, if it's plus, we can multiply m and n. If it's minus, we can divide. If the coefficients do not equal to 1 to begin with, so let's say like there's a number in front, we need to move that coefficient as an exponent using that log property. Now your equation should have the form of this. And this is where we need to get rid of the logarithm. So we can go back to exponential form by saying taking the base, raise it to the constant, equaling to d. And we're going to solve for the variable. Now you must check your answer back into the original equation because remember the domain of logarithms are positive numbers. If you recall the graph, remember we studied, had a graph that looked like this, where your domain was from 0 to infinity, not including 0. It had to be all positive numbers. And so that's why we need to check our answers back into the original equation. So let's just start with this first example. Fairly simple. We have a single log of an expression equals to a constant. So we're really already to this format. So we need to get rid of the logarithm by getting it into exponential form. So our base is 5. We need to raise it to the constant of 2, and it equals to the expression. So we just have 25 equals 3x plus 2. Subtract 2 from both sides, and divide by 3. Now we need to check our answer. Now all we're checking is to make sure we're taking the log of numbers greater than 0. So if I put in 23 thirds into this expression, 3 times 23 thirds plus 2, oops, that should be like that, then we would have 23 plus 2 equals to 25, and that's a positive number. Or you could have just looked at it and said it's all positive, and it's positive. Okay, here we have the natural log. Recall that the natural log is base e. Okay, so it's in the same format as our first example. We need to take the base, raise it to the constant, equals to the expression. So we have, let's say we need to solve for x, so we need to subtract 2 and divide by 4. So we have e cubed minus 2 over 4 is equal to x. You can leave your answer like that. You are welcome to use a calculator to get a decimal approximation, but that's good enough. Now again, we need to check our answer into that expression, making sure that it's greater than 0. So I have 4 times e cubed minus 2 divided by 4 plus 2. So we have e cubed minus 2 plus 2, and we have e cubed. Now e is almost 3. It's positive, and that's all we're looking for, making sure that our values are greater than 0. Our next two examples are a little bit more complicated. We now have two logarithms, and we need to combine them. So we use our property that says if this is plus, we can multiply those. So we have log of x plus 2 times x minus 1 equals to 1. I'm going to go ahead and multiply that out. So we have x squared plus x minus 2 is equal to 1. Now we have it in the format of the log of something equals a constant. But what is the base? Remember, it is understood to be base 10 if that little number is not there. So we have 10 to the first power is equal to our expression. So this is a trinomial or a quadratic, so I need to set it equal to 0. So I'm going to subtract 10 from both sides. And then I'm going to factor this trinomial. and set each factor equal to 0 and solve. So I have two answers, and just because one answer is negative doesn't mean you throw it out. Be careful. You want to check it in each one of these expressions in the original answer. So if I have to have x, which is negative 4 plus 2, the log of that. Well, that would be the log of negative 2. You cannot take the log of something negative, so we're going to throw that out. Don't erase it, just put a mark through it. Then let's check our 3. So we have the log of 3 plus 2, which would be positive, and the log of 3 minus 1, which would be also positive. But again, just because x is negative doesn't mean you just automatically throw it out. Every once in a while, that can work. It just depends on back into the original equation. All right, so let's look at this. Property of log. Now we have subtraction. That says we can divide these two expressions equals to our constant. So it's very clear that our base is 2. We raise it to the constant of 2 equals to our expression. So we need to get rid of the fractions, so I'm going to multiply both sides by our denominator of x plus 2. So that's going to reduce out. This is 4, so I'm going to distribute. So 4 times x and 4 times 2 is equal to x squared minus 3x. So again, I have a quadratic. I want to set it equal to 0. I like my x squares positive, so I'm going to subtract 4x, and I'm going to subtract 8 from both sides of the equation. So I have x squared minus 7x minus 8 equals to 0. So once again, we have a trinomial, easy to factor, and we set each equal to 0 and solve for x. And once again, I have two numbers. I have to check it back into my expression. So I have log base 2 of x squared. That would be 64 minus 3 times 8. So that would be a positive number. And then I need to check it into this 8 plus 2. That's also positive. So 8 looks good. But what about negative 1? So I have the log of negative 1 squared. So that's 1. And then negative 3 times negative 1 would be positive 3. That's positive 4. That's okay. Now I need to check it in here. So I have negative 1 plus 2. Well, that's positive 1. So this is a great example of where a negative can be a solution. Want to emphasize, you've got to check it back into your original equation.